everyone. Just welcome back our class. And I didn't finish grading our test paper yet, and I think I will return your test paper next week and explain the questions over there. So today we can move to chapter 5.2. 5.2. Just a reminder. Our final exam will be on week 17. Week 17. That is June 9th. June 9th. Questions? And sure, if your grade is too horrible, I will call you to have a supplement exam on this day. If that is okay, I will not call you. So don't worry. At least as the policy, you know, the chairman of our department, I mean IT department, Dr. Chen, he emphasized the attendance of students, the attendance. Okay, so the policy is at least 2/3. That's the policy. I cannot change it. But in our department, we have this kind of restriction, so we don't need to care about that. Okay, and final exam will be on this time. And we need to learn some concept, including normal distribution, t-test, chi-square, f-test. And I think that's enough because for the introduction of the statistics is enough. But in the future, if you have chance to study furthermore about the statistics or economic theories, you need more background of the statistics, not my background, because this class is very easy. Introduction, very entry level. Okay. Okay, let's move here. Okay. Chapter 5.2, binomial probability distribution. Personally, I think this kind of importance is just fair. Okay, but next section, means and standard deviation of binomial distribution is a little bit more important than this one. Okay, let's move here. Section 5.1 introduced the concept of a probability distribution. The focus of the section was discrete probability. That is not continuous. Discrete probability distribution is called PDF, similar to the file format PDF. Okay, and find a PDF for a situation you usually needed to actually conduct the experiment and collect data. Then you can calculate the experimental probabilities. Normally, you cannot calculate the theoretical probability instead. However, there are certain types of experiment that allow you to calculate theoretical probability. One of those types is called a binomial experiment. Okay. Probability of binomial experiments. Fixed number trials and the n is in italic, which means the experiment is repeated at a specific number of times. For example, it conducts for 5 times, 10 times, 11 times, 12 times. That is n. Okay. The n trials are independent, which means what happens on one trial does not affect the outcomes of other trials. Okay, this is very important assumption. And number 3, there are only 2 outcomes which are called a success and a failure. SOF, success or failure. The probability of success does not change from trial to trial, where the P, the lowercase p, means probability of success, and Q, probability of failure. Here, the equation is Q equals 1 minus P. If you know you have a binomial experiment, then you can calculate the binomial probabilities This is important because binomial probability come up often in real life. For example, there are some cases here. Toss a fair coin 10 times and find the probability of getting two heads. Okay. Question 20 people in class and look for the probability of more than half being women. Oh, okay. The probability. Shoot 5 arrows at a target and find the probability of hit it in 5 times. The outcomes just two kinds. One is success, one is failure. Okay, and here it's very similar. One coin has two sides, the head and the rail, the head or the rail. Question of people in class, we don't discuss about the third gender or different gender. We just think about the gender have man and woman, the two kind of genders, okay, female and male. Thus, it fits the criteria of binomial. Okay, and here, shoot 5 arrows at a target and find the probability of hitting it for 5 times. And there are two outcomes: get it and miss it. Get it, miss it, get it, miss it. And the question is the probability of hitting it 5 times. It means all 5 shots are hitting the arrows. What's the probability? Okay, and now let's look at the example 5.2.1. Suppose you are given a 3-question multiple choice test. Each question has 4 responses and only one is correct. Suppose you want to find the probability that you can just guess at an answer and get 2 questions right. Teachers do this all the time when they make up multiple choice tests to see if students still pass without studying. Okay, in most cases, the student can't. To help with the idea you are going to guess, suppose the test is in Martian. Okay, and A, what is the random variable? And the answer is the number of correct answers. For instance, question B, is the binomial experiment? Yeah, there are 3 questions. And each question is a trial, so that there are fixed number of trials. In this case, the repeated number of repeated times is 3. Getting the first question right has no effect on getting the second or the third question right. Thus, the trials are independent. It's a very important assumption before we start the trials. Either you get the question right or you get it wrong, so that there are only 2 outcomes, right or wrong, success or failure. In this case, the success is getting the question right. The answer number 4, the probability of getting a question right is 1 out of 4. This is the same for every trial since the question has 4 responses. And it's very similar like this. Like this one. Question number 1. There are 4 choices. Choices A, choices B, choices C, choice D. Okay, there are 4 choices here, and only one is correct. Assume the first one, that is A, correct. And question number 2, choice A, choice B, choice C, and choice D. And assume the correct answer is D. And question number 3, question number 3, 4 choices. Choices A, B, C, and D. Okay, and assume the answer is C. Okay, if the student do not study or the student cannot answer it, guess the answer is the best way. And there are four choices: A, B, C, and D. Thus, the probability the student gets the correct answer, that is 1/4. The probability is 1/4. Okay, and the same one as for the question number 2, 1/4, 1/4. Okay, that's it. That's it. Right, let me. Okay. So this is a binomial experiment since all the properties are met. Okay, question number 3, question C. What's the probability of getting 2 questions right? What's the probability of get a question right? Okay, question C. To answer this question, start with the sample space that is right, wrong, wrong, like this one. There are 8 combinations, and it means the second question right and the third question wrong, like this one. The similar for the other outcomes. Now the event space for getting 2 right, that could be right, and 1 wrong. Question number 3 is wrong. Question number 2 is wrong. Question number 1 is wrong. What did you in the chapter 4 was just to find 3 divided by 8. Like this one. But this will not be right in this case because the probability getting right and getting wrong is different. It's different. Let me show you here. Okay, 1/4 is the probability of getting it right. If I choose that, for example, if I choose B, C, or D, that is wrong. Thus, the probability of the wrong, okay, what happened here? Wrong, W, it means wrong, that is 2/3, sorry, 3/4, and 3/4. Here, 1/4, it means correct or right. Maybe I can write R. Correct or right. 1/4. Okay, then we can know one thing. There are 3 outcomes. The probability of the question number 1 is correct. That's 1/4. And probability of this one, that is 1/4 square and 3/4. That is 1/4 square times 3/4. The power is 1. Thus, here is 1/16 multiply 3/4 64. And now we have 3 sets of this one. We have 3 sets of this one. We can multiply it by 3. The answer will be, the denominator is 64 and the numerator is 9. 9 over 64. That is the answer of this one. So it's very similar. It's a little bit different, but we can calculate it very easily. Okay, how about let me be quiet for 1 minute. You can take a note of this one. Okay, any question about this example? Okay, let's move to next. Okay, I will explain just the first example, then let's move to the next one. Next question. Okay, chapter 5.3, mean and standard deviation of binomial distribution. Okay, if you list all possible values of x in binomial distribution, you get the binomial probability distribution. Now you can draw a histogram of the PDF, find the mean, variance, and standard deviation of it. For a general discrete probability distribution, you can find the mean, the variance, and the standard deviation for a PDF using the general formula. Mean, the population mean is summation x times the probability. Here is the mean. Here is the mean. Okay, then next, here is the variance, sigma square. Here is the variance. Here variance. Okay, if you forget the definition of the variance, you can review the chapter number 3. Variance is summation x minus the mean and take us the value of square and times the probability. And here sigma is the standard deviation. That is the summation of this one and take a square root of it. So you don't need to memorize those one. And in our course, I will open everything for you, so you don't need to. Sure, if you can memorize it, it's good. It's good. Okay. The formula are useful, but if you know the type of distribution, like a binomial, when you can find the mean and standard deviation using easier formula, they are derived from the general formula. And here, note for a binomial distribution, mu or the mean, the expected number of successes, sigma squared, the variance, and sigma, the standard deviation for the number of success are given by the formula like this one. Mean equals tested number, the repeated number, times success, the success probability, and the standard deviation, the variance equals n times p times q, and sigma, it means the standard deviation is square root of n times p times q, and where the p is the probability of success and q is 1 minus p. Okay, let's move. Let's check the question 5.3.1. Finding the probability distribution, mean, variance, and standard deviation of binomial distribution. Okay, here we study the question first, then we will review the questions for a second. Okay. Look, when looking at a person's eye color, it turns out when 1% of the people in the world has green eyes, the reference is what the percentage of, published in 2013. Okay. Consider a group of 20 people. Okay, 20 people. Okay. State the random variable. First question, state the random variable. The random variable x equals the number of people who have green eyes. Who have green eyes. Okay, actually, according to statistical data, the probability is 1%. Okay. Question number B. Write a probability distribution. And here, in this case, you need to write each value of x and its corresponding probability. It is easy. Okay. How about let me finish this example, then we can have a break. It is easy to do this by using the binomial PDF command, but do not put the R value. You may want to set your calculator to only 3 decimal places. So it is easier to see the value and you don't need much more precision than that. The command will look at like this one. Sure, I will tell you, I will use the Google Office instead of the R. The example like this one. Probability of distribution of number of people with green eyes. X is 1, the probability 0.818. Sorry, the 0. The probability the person is green eyes, the probability is 0.165. 2 people in 20 people, the probability the two people have green eye, the probability is 0.016. Sure, when the number increasing from 1 to 20, the probability is going down. And in this case, it takes only 3 decimals. So after that, it's less than 0.00. And we can see only 0 here. Okay, and question. Please draw a histogram and find the mean, find the variance, and find the standard deviation. Okay, let's check the histogram. And here, 0 people get the 0 people has green eye. The probability is about 0.8, very high. One people have green eye, that's about 0.1, like this one. Two people have green eye, wow, it's very horrible, like this one. Histogram created on this one, okay. Okay, let's look at the D. Since it's binomial, when you use the formula, the mean equals NP, the repeated number, times the probability of the event, of the outcome. So then the mu is 20, the repeated number, and 0.01, the probability. Thus, the average is 0.2 people in 20 people has the blue eye. You may say, oh, it's impossible. All people is alive or dead, but we cannot say 0.2 people. We can say that, sure, it's math calculation. We can do that. Okay, you expect to, on the average of 20 people, less than 1, that will have the green eyes, less than 1. Question E, the standard deviation. So, the variance. The variance, the formula is sigma square, the variance, equals n times p times q. P, that is 0.01. Let me have this one. We know that sigma square, that is n times p times q. We know that n is 20. Probability, that is 0.01, and q, that is 1 minus 0.01. We can get 20 times 0.01 times 0.99. The answer is about 0.198 people square. Okay. You may be shocked why people, the unit, one person, 2 people, can we say the people square? Sure, it's a kind of calculation, but when we take a square root of this, the answer is very close to 0.445. Okay, and okay, questions? Otherwise, we can have a break, then I will take attendance after the break. Okay, see you later.